Hi, Lotek. Yes, it's very confusing, and you, in a way, right. It depends. Your battery to the inverter would be the source. So the source is always the power that goes towards the load. So the load is where you pull the power. So most of it are used, the DC breakers, non-polarity breakers are mostly used in your PV combiner box, as a, for safety and also to disconnect. So especially in South Africa, you can use the normal disconnect, but especially the non-polarity breakers has its advantages because it's got thermal trip, it's got short circuit protection, and it's got overload protection. So if you rate them right, you've got it covered. Non-polarity breakers are not very commonly used between batteries and your inverter, especially because there are too many, there's just too many polarity breakers in the market. And that was one of my main fights here in South Africa, is to put the non-polarity breakers in instead of the fuses for lots of reasons, especially for the thermal trip. Especially on the lithium batteries, and also overcurrent and short circuit. But if you can use a polarity breaker, that would be fatal, because a battery can arc much more amps than a solar panel, so the fire will be dramatic. So yeah. But manufacturers themselves, battery manufacturers, use non-polarity breakers, some of them. Even if you look in the OEM's manuals, they will say a DC breaker. Sometimes they must just specify non-polarity breakers. But when they're inside, they use it as protection. Because I had a client, I put the non-polarity DC breaker, 125 amp on lithium batteries. He had two, but we only capped it until 80 amps. So there are some play. And he phoned me later on and said to me, listen, he doesn't know what's wrong. The thing keeps on tripping. It's got a warranty on it. So I went to him, have a look, and looked at the hot connection or what's wrong. Why does it trip all the time? We got to it. We used the manufacturers, the OEM's battery cables that they supply. They've got these special clips. I like to make my own, but those clips, gonna name the brand Dynas Batteries. There's lots of them. Polarity, I think, has it, but I like it where I can make my own crimps and my own cables, especially in South Africa. Quality copper cables. So where it bent, it became very hot, and it also almost melted. So every time it kept on tripping because it had a thermal trip in. If it was a fuse, it would just supply, and the wire would have get hotter and hotter until maybe a point where there could be just sparks flying around. But yeah, so the source basically on the PV panels, your panels are the source to your MPPT, and then your batteries to your inverter. But yeah, most of all, the flow of the current is something that we must remember. DC voltage doesn't have a live and a neutral, a positive and a negative, really. It goes from source to load. So it always, basically, that's why hotspots in your panels are so draining your system, because it creates a load, resistance. Where there's resistance, everything will go there. That's why a hot connection is so dangerous, because it might pull more there than the load, and then that will become the load. So yeah, for safety, definitely always hot connections. But yeah, there's so many brilliant products in the market, and we try to push it, or not push it, but bring it to market. But the people doesn't see the risks, or the installers doesn't. And some of the suppliers, they keep on pushing products, but now the products are finished. Now suddenly they look into it, which is a good thing. So yeah, thermarest is something you can have a look on, especially on thermal. As soon as it reaches above a certain temperature, I think it's 80, then it's like a wire in it, and then it will burn, so it will become a normally closed circuit will become normally open, which gives you an alarm that you can put on the SMS. Prevention is better than mitigation, or suppression, so but yeah, I hope it helps. So just remember, the source is always where the power comes from and goes to. It's almost like gravity, it flows from the higher place to the lower place. Lots of people, I see DC electricity much like water. Some people say it doesn't work like that. I see it like it most of the time, not always in all circumstances. And I am not a good plumber, so maybe that's why. But it's almost like gravity on the water. So, the higher load, so your panels will give you more volts and more amps that are supposed to be in your batteries. So it goes through MPPT and then it goes towards your batteries. So that's why that's the load, and then the load will be from your batteries, pulling it out, pushing it back to the inverter that goes to your supply, your electricity. So hopefully this helps, but thanks for the question. It's always difficult. It's a long video, but this is specifically for you, and maybe some other people can help, could be from that as well. And if I'm wrong, please help me right.